We have another equation here. It's an equation of a straight line. X to the 1, y to the 1. That's when you know it's a straight line. The power of x, the exponent of x and y both equals 1. So the question says, first find the intercepts and use the intercepts to graph the function. Now remember, the x-intercept is the point where the graph crosses the x-axis, and any point on the x-axis looks like a, 0. A can be anything, and 0 is the y-coordinate, which is always fixed. This is always the case. So that's how we find the x-intercept. For the x-intercept, we plug in y equals 0 and then solve for x. So we add 4 on both sides and we get 2x equals 4. We divide both sides by 2 and we get x equals 2. So the graph of the straight line crosses the x-axis at x equals 2, and the point is 2, 0. Remember that any point on the x-axis, the y is always equal to 0. The y-intercept, remember, is the point where the graph crosses the y-axis, and on the y-axis, x is always equal to 0. So y equals 2x minus 4. X is 0. So y equals 2 times 0 minus 4. So y equals -4. So what is the point where the graph crosses the y-axis? X is always 0 on the y-axis, and it crosses the point y equals -4. So we're going to plot these points on the graph first. The first point is the x-intercept 2, 0. X-intercept lies on the x-axis, 2 to the right from the center. So 1, 2. This is the point 2, 0. The y-intercept is 0, -4. X is 0 and y goes to the negative side of the y-axis. So 1, 2, 3, 4. That's -4. So this is the point 0, -4. We've plotted the two intercepts, the x-intercept and the y-intercept. Now all we have to do is join these 2 points with a straight line. And that's the graph of the function. Here's another equation. Y equals -1/3 x plus 2. This is an equation of a straight line. You know that because the exponents on the x and the y equals 1. We're going to use the intercepts to graph this equation, which is a straight line. So first let's find the x-intercept. X-intercept is the point where the graph crosses the x-axis. Any point on the x-axis has y-coordinate 0, and that's where we begin. We plug in y equals 0 into the equation. Y equals -1/3 x plus 2. Once we plug in y equals 0 into the equation, we solve for x, and that gives us the x-intercept. So let's add, it could be anything, but we can add 1/3 x on both sides. So 1/3 x is equal to 2, and then we solve for x by multiplying both sides with the reciprocal of the fraction, which is 3/1. That becomes a 1, so that's x equals 6. So the point where the graph crosses the x-axis is at 6. And the y-coordinate is always 0. The y-intercept, you know that the y-intercept is the point where the graph crosses the y-axis, and the x-coordinate of the y-intercept is 0. So we have y equals negative 1/3 x plus 2. We plug in x equals 0 because for the y-intercept that lies on the y-axis, the x-coordinate is always 0. Once we plug in 0 for x, we solve for y. So that's negative 1/3 times 0 plus 2. And that gives us y equals 0 plus 2, which is 2. So the point where the graph crosses the y-axis is 0, 2. So let's plot these points. Let's plot the x 1, 2, 3, 4, 5, 6. That is 6, 0. That is the x-intercept, the point where the graph crosses the x-axis. 0, 2 is on the y-axis. You go 2 up, 2 units up, and that's the point 0, 2. Now we join these two with a straight line, and that's the equation of, or rather that is the graph of our line for which we have the equation. So basically for the x-intercept, just remember this, that lies on the x-intercept, that lies on the x-axis, substitute y equals 0. For the y-intercept and solve for x. For the y-intercept, we plug in x equals 0 because it lies on the y-axis, and we solve for x. Now we've looked at equations of straight lines. We've seen examples. Let's say negative 1/3 x plus 1. We've seen examples like 2x plus 3y equals 4. We've seen x minus 2y minus 1 equals 0. All these are equations of straight lines. Y is to the 1, x is to the 1, x is to the 1, y is to the 1. As long as the exponent on x and y equals 1, we know that the equation is a straight line. But let's look at equations that look like y equals 5, y equals negative 3, x equals 7, or x equals negative 4. These are also straight lines. In each of these, for example, look at y equals 5, the x is missing. Y equals negative 3, the x is missing. X equals 7, the y is missing, the y term is missing. And x equals negative 4, the y term is missing. Now let's try to graph each one of them. Y equals 5. If I had to graph this, no matter what I plug in for x, the y is always going to be equal to 5. Let's say I plug in x equals 1, y is 5. X equals 0, y is 5. X equals 7, y is 5. No matter what I plug in for x, my y is always going to be 5. That's what y equals 5 means. So what do the points look like? 1, 5, 0, 5, 7, 5. If I plug in a negative 1, that's also 5. All we need is 2 points. So let's plot any 2 points. 0, 5. 0, 5 is, this is your x. X is 0, y is 5. So 1, 2, 3, 4, 5. So that is x is 0, y is 5. You've gone up 5, so that tells me that y is 5. Let's look at negative 1, 5. So this is negative 1, and that's 5. 1, 5. So this is 1, 5. This is negative 1, 5. Remember that the y is always going to be equal to 5. The heights of these points will always be 5, no matter what x is. No matter what I plug in for x, that's what it looks like. Now, if I join these points with a line, what I get is a horizontal line. What's constant throughout is the y coordinates of any point, any of the points that sit on the line. So it sits 5 units above the x-axis, and that is the line y equals 5. Now you can think about what the line y equals negative 3 looks like. No matter what I plug in for x, my y is always going to be negative 3. So let's say I plug in x equals 0, my y is 1, 2, negative 3. That's what the y is. So 0, negative 3. If I plug in 4, y is still negative 3. 1, 2, 3, 4, and y is negative 3. So that's 4, negative 3. Remember, the y coordinate is always going to be negative 3. So no matter what I plug in for x, do you see that the points are going to line up this way? So y equals negative 3 is this line that is 3 units below the x-axis. Now let's look at the other lines. X equals 7. No matter what the y is, the x is always going to be equal to 7. So what does that look like? So for x equals 7, if I plug in y equals 1, x is going to equal 7. Y equals 2, x is 7. Y equals 3, x is 7. X is always equal to 7. Now let's see what that looks like. 1, 2, 3, 4, 5, 6, 7. That's x equals 7. And any point that has x equals 7 throughout is going to sit on this line. This, for example, is the point 7, 2. The height is 2, y is 2, x is still 7 because it passes through this. Let's look at this point. It's we start again. This is my x-axis. So 1, 2, 3, 4, 5, 6, 7. If x is 7 always, then your line is going to be a vertical line 7 units to the right of the y-axis. Now what does x equals negative 4 look like? No matter what y is, x is always going to be equal to negative 4. So 1, 2, 3, and that's negative 4. If x is always negative 4, no matter what y is, y can range from negative infinity to positive infinity, but x is always going to equal negative 4. And here y is always going to equal 7. So anything in the form x equals a number, is going to be a vertical line, and any equation y equals b is always going to be equal to a horizontal line. That's how vertical and horizontal lines work.